Good afternoon students, welcome to my chemistry class. Today we are going to study about Unit 7, Equilibrium. In that we are going to study about theories of acids and bases. Before that, can you give some examples of acids? Which is the acid present in lemon? Citric acid. Which acid is present in milk? Yes, you are right, it's lactic acid. Now, which acid is known as the king of chemicals? Sulfuric acid. Any other examples, Hydrochloric acid. Right? Now, example of base. What are the examples of bases? Potassium hydroxide, okay, sodium hydroxide, etc. Now, in your lower classes, you have studied what are the properties of acids and bases. What happens when an acid comes in contact with the skin? It burns the skin. What about base? It is soapy or it's slippery to touch. Next, what is the taste of acid? It is sour. That is, if the taste of, what is the taste of lemon? It's sour, right? But all chemicals and bases we cannot taste. For example, sulfuric acid, can we taste it? No, it's very dangerous for your health. What is the taste of base? It tastes bitter. Now, any other properties, What about litmus test? See, for acid, it is blue litmus, it is changing blue litmus to red. Now, I will give you one clue how to study this. Acid, right? Acid turns blue litmus red. Think it as bar. It is blue litmus red. Just the opposite happens to base. Base is red litmus blue. That is base. You just remember this one. How will you measure the strength of acid or base? Using pH scale. You have seen a pH scale, right? A pH paper. See, it starts from 0, 1, 2, 3, 4, 5, 6, 7. Goes like up to 14. 8, 9, 10. It goes like this. Okay. We know that the pH of water is neutral, that is 7. This is the neutral. Here the lower members comes under acids. They are acids and the higher members are bases. This also you have studied in your lower classes. What happens when an acid and base combines together? Acid plus base gives, yes, salt and water. Can you give me one example? Acid, Hcl, base, sodium hydroxide, NaOH. What it gives? Salt, right? That is NaCl, right? NaCl plus, what is left there? Water. So it forms salt and water. What is this reaction known as? Yes, you are correct. It's neutralization reaction. Now let's see a very important topic in this chapter, that is theories of acids and bases. There are three main theories for acids and bases. First one is Arrhenius Theory. Second one, Bronsted-Lowry Concept. And third one, Lewis acid. First one, Arrhenius Theory. Second one, Bronsted-Lowry Concept. And third one is Lewis concept. So we have to study each theory in detail. So what is Arrhenius theory? There is one condition for this Arrhenius theory, that is the molecule should be dissolved in water. Okay. Now if you are taking a beaker, there is water in that. So the condition of Arrhenius theory is the molecule should be dissolved in water. Now let's see what is Arrhenius theory says about acid. Now he says acid is a substance that donates a proton, that is H plus ion. Okay, acid is substance which donate a proton or donate H plus ions, and base is a substance which donates OH minus ion. So let's see the example of HCl. HCl is an acid. So it produces what? H plus ions. So it gives H plus and Cl minus when it is dissolved in water. That is aqueous solution. The condition is that the molecule should be dissolved in water. See, I have taken the beaker which is containing water. So in that we are adding what? HCl. So when HCl is added to this beaker, it dissociates into H plus and Cl minus, or it produces a proton. Now I'll take another example of acid. Now this is a strong acid, HCl. Can you name a weak acid? Correct, acetic acid, that is CH3COOH. So it is also in aqueous solution. It gives CH3CO minus plus H plus. See, this molecule produces a H plus ion. This is known as acetate ion. Now let's see the example of base. Sodium hydroxide is a strong base. Okay, in aqueous solution, it gives, it produces Na plus and OH minus. See, base is a substance which donates OH minus. Can you give me a weak base? Ammonium hydroxide, NH4OH. It gives, in aqueous solution, it gives NH4 plus and OH plus. So the Arrhenius theory says that an acid produces H plus ions when only dissolved in water. Similarly, a base produces OH minus ions when dissolved in water. So the condition is that should be dissolved in water. Okay. So that is an acid, Arrhenius acid and Arrhenius base. Is it clear? Okay. Now there are certain limitations for each theory. So here also Arrhenius theory has certain limitations. First one is, I have already told that the molecule should be dissolved in water. Then only Arrhenius theory takes place. So we can say that Arrhenius theory is applicable to only aqueous solution. Applicable only to aqueous solutions. Second one is, it does not explain the acidic nature of substances which do not contain H plus ions. That is, for example, HCl I told you. HCl gives H plus and Cl minus. If there is hydrogen is there, that is, if a molecule gives H plus ions, then we can say it is acidic. For whom? For Arrhenius theory. But then also there are certain molecules which do not contain H plus, but still they are what? They are still acids. For example, carbon dioxide, sulfur dioxide. Any other example? Copper sulfate. They also shows acidic nature. But according to Arrhenius theory, the molecule should contain what? H plus ions. Or H. A hydrogen atom should be there. Clear? So that is the second point. It does not explain the acidic nature. That is, it does not explain the acidic nature of substances which do not contain hydrogen. So third limitation is, it does not explain the basic nature of substances which do not contain OH groups. So what are the examples of that? Ammonia. It doesn't contain OH group. For example, carbon dioxide, sulfur dioxide. Any other example? Copper sulfate. They also shows acidic nature. But according to Arrhenius theory, the molecule should contain what? H plus ions. Or H. A hydrogen atom should be there. Clear? So that is the second point. It does not explain the acidic nature. That is, it does not explain the acidic nature of substances which do not contain hydrogen. So third limitation is it does not explain the basic nature of substances which do not contain OH groups. So what are the examples of that? Ammonia. It doesn't contain OH group, but still it is a base. Similarly, sodium carbonate. It does not contain OH group, but still it is a base. So we can say these are the three properties or three limitations that led to another theory, Bronsted-Lowry concept. There are two scientists here, Bronsted and Lowry. So Lowry is an English chemist and Bronsted is a Danish chemist. So they together, independently and simultaneously, they made experiments and found out another theory, that is Bronsted-Lowry concept. Now in this theory, unlike this Arrhenius theory, we have told that that molecule should be dissolved in water. But here there is nothing like that the molecule should be dissolved in water. So the first condition is that there is nothing like molecule should be dissolved in water. Now according to Bronsted-Lowry concept, what is an acid? Acid gives H plus ions, or we can say it donates a proton. Okay? Acid is a substance which donates a proton. Now what about base? Base is a substance which accepts a proton. Okay. So let's see there are some examples. Now let's see one example. That is a reaction between Hcl and Ns3. Now, according to the Bronsted-Lowry concept, acid is a substance which donates H plus ions. So it forms. Now here, which one is the acid? Okay, as a substance which donates H plus ions. So this one will be the acid. So donates H plus ions means what? It becomes Cl minus. Okay. And this H plus donates one H plus ions, right? This H plus will be accepted by ammonia and it forms NH4 plus. So this is proton donor. The acid is a substance which donates a proton and becomes Cl minus. Base is a substance which accepts a proton and becomes proton acceptor. Now in this, Hcl and Cl minus, they are known as conjugate acid base pairs. Okay, this is conjugate acid. Here Hcl and Cl minus and NH3 and NH4 plus, they are known as conjugate acid base pairs. So why they are known as conjugate acid base pairs means they differ by a hydrogen or proton. Okay, it differs by a hydrogen. There is no hydrogen here. There is no one hydrogen is less here. Okay, so differs by a proton. So it is known as conjugate acid base pairs. Okay, we have understood this Bronsted-Lowry concept. So according to Bronsted-Lowry, acid is substance which donates a proton. Here who donates proton? Acid. This one Hcl. Who accepts a proton? NH3. Okay. Now let's see one example in your NCERT textbook, that is CH3COH plus water gives CH3CO minus plus H3O plus. You have to identify which one is the Bronsted acid and which one is the Bronsted base. So according to Bronsted acid, acid is substance which donates H plus ions, right? Proton donor. Proton donor is proton acceptor. Now see, CH3COH is doing what? It's donating its proton, right? So it becomes what? CH3CO minus. So it donates a proton, so it is a acid. Okay. Now the H plus ions have been donated and becomes what? CH3CO minus. So what is that? Conjugate base. That is, they are differing by one hydrogen atom. Correct? So it is a conjugate base. Next one is say water. Water, what is doing? Water is accepting that H plus ions from CH3COH. So it becomes what? A base, right? And this one is differing by an H plus. So it is a conjugate acid. So clear? So these type of questions may come. You have to identify which one is a Bronsted acid and which one is a Bronsted base. Okay. Now there is another theory because of the limitations. There is another theory led to. There is still a broader concept, okay, which we are using nowadays. It's a broader concept of acids and bases. That is Lewis theory, which is the most accepted one. Okay. So what is Lewis theory? What is a Lewis acid and what is a Lewis base? Okay. Now I will give you one example. From that we can understand what is a Lewis acid and what is a Lewis base. Let's see one example, that is BF3 molecule. Boron, right? Boron is the central atom. Central atom is boron. Now, what is the atomic number of boron? 5. Atomic number of boron is 5. So, what will be the electronic configuration? 2, 3. Electronic configuration will be 2, 3. So, the valence electrons will be 3. Now, these 3 electrons will be satisfied by whom? Fluorine atoms, right? So fluorine needs one more electron because fluorine, the atomic number is 9 and that is 2, 7. It needs one more electron to get octet, to be octet. So 3 fluorine atoms are there. So 3 atoms will come and join here. Makes a covalent bond, right? So here F and here F. Now see, fluorine, 7 electrons are there in the outermost shell. So we can represent the outer unshared pairs of electrons 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 and 7. That is shared with the boron. Here also unshared pairs 1, 2, 3, 4, 5, 6 and 7. Right? Here also 1, 2, 3, 4 and 6 and 7. So shared with the electrons. See? Now boron has how many electrons? 1, 2, 3. Here also with fluorine 4, 5, 6. Right? That is one bond makes, that is 2 electrons makes one bond. So there are 2 electrons here. 1, 2, 3, 4, 5, 6. So there are 6 electrons in the outermost shell, right? 6 electrons. So we can say it is it completing the octet? No, it is deficient, right? It is electron deficit. Right? Electron deficit. Doesn't contain 8 electrons. So it needs 2 more electrons to complete the octet. Who will give? There is one molecule. Okay? So that is ammonia molecule. See, ammonia is Ns3. So nitrogen. We know the atomic number of nitrogen is 7. So electronic configuration is 2, 5. So 5 means it needs 3 more electrons. It is satisfied by hydrogen atoms 1, 2, 3, 4, 5, 6. It has a lone pairs of electrons, right? Ammonia. So they can give 2 electrons to BF3 molecule, right? BF3 molecule, they can give this 2 electrons. Let's see BF3. It is, the reaction will be with ammonia. I told that there is a lone pairs of electrons in ammonia. So it will donate its electrons to boron. So it becomes what? The octet of nitrogen is complete here. So it donates its electron to boron. So it gets 2 more electrons, so it will be 8. So it donates donated electron means nitrogen will be 6. Now this bond we call it as coordinate covalent bond. So what is a Lewis acid and Lewis base here? Let's see. Boron has a deficit of electrons. It doesn't have, it needs 2 more electrons. The 2 more electrons is donated by ammonia. So it gets 2 electrons or it accepts a pair of electrons. That is known as a Lewis acid. So it accepts a proton. So it is known as Lewis acid, not proton. It accepts the electron. So it is a Lewis acid. And which one who donates an electron? That is ammonia. So it is a Lewis base. So Lewis theory, what is according to Lewis, what is a Lewis acid? Electron pair acceptor is known as Lewis acid, and electron pair donor. Okay, this is acceptor. Okay, accepts. This is donates an electron pair. So it is known as Lewis base. Okay, so these are the 3 theories we have studied. Okay, so this is the coordinate bond form. Now let's summarize what all theories we have studied. That is Arrhenius theory, Bronsted-Lowry concept, and Lewis theory. So let's summarize what are the theories we have studied. First one is Arrhenius. So according to Arrhenius theory, what is an acid? Acid is a substance which donates H plus ions, right? And what is base? Base is substance which accepts proton. Donates OH minus, right? That is Arrhenius theory. Okay. Next one is what? Bronsted-Lowry concept. Bronsted-Lowry concept, what according to him, what is an acid? Acid is a proton donor. And base is a substance that is proton acceptor. Then the third one is Lewis concept. What is an acid according to him? Acid is a electron pair acceptor. Okay, just opposite of this one, electron pair acceptor. And what is a base? Electron pair donor. Okay, it's clear? So these are the 3 theories you have to study. Arrhenius theory, Bronsted concept, and Lewis concept. There are certain examples also. Okay, so thank you for watching. Let's see in the next video.